Professor Wang is a Canada Research Chair and professor in the Department of Electrical and Computer Engineering. He's a global leader in wireless communications, the Internet of Things, and machine learning, fields that are reshaping how we live, work, and connect. Over the course of his career, Professor Wang has made foundational contributions to the development of next-generation communication systems, including 5G and beyond. His work bridges the gap between theoretical research and real-world application, and his innovations, which are reflected in more than 35 different patents, have influenced both industry standards and public policy around the globe. He's held prestigious roles as a fellow of both the Canadian Academy of Engineering and the Engineering Institute of Canada, and his collaborations with industry, government, and international partners speak to the broad relevance and reach of his research. We're honored to celebrate his achievements today. Please join me in welcoming Professor Wang.
Good afternoon, everyone. It's really a great pleasure to be here and share some thoughts on one important but very interesting topic: how to achieve value realization in future 5G and 6G enabled intelligent systems. In the last 30, 40 years, wireless infrastructure has evolved as the most important platform of our society. As the technology quickly converges with AI smart applications, we can imagine it will continuously redefine the way we work, play, collaborate, and even think. The challenge here is that the design objectives and performance criteria for the future computing systems are quickly evolving. Now, today, I want to share the challenge on value realization and the research innovation at Western on how we achieve the values in the future smart applications. Now, my related research activity for value realization is shown in this word cloud, which include the effective 5G, 6G communications, integrative security, privacy, and trust provisioning, and goal-oriented system orchestration. Now, specifically, I will share the thoughts today on three aspects: the evolution of wireless technologies from 1G to 6G, the value realization in 6G-enabled intelligent systems, as well as our research innovation along this roadmap. So let's talk about the evolving goal and the challenges from 1G to 6G. Now, long story short, between 1G to 4G, which is between 1980s to around 2010, so we achieved one single objective: networking everyone through communication networks. So the performance evaluation criteria is about the connectivity, data rate, and coverage. Now, as we evolve into 5G and 6G, the convergence of communication network and vertical industries is quickly occurring. And we are expected 5G and 6G networks to support both human-to-human communication, but also including human-to-machine and machine-to-machine communications. The future communication infrastructure is an enabling platform that assists humans to observe, analyze, and control of our physical world. It empowers us as a critical platform. And simply because of so many important applications to be enabled by 5G and 6G networks, how do we evaluate the design? How do we evaluate its value? And this could be extremely challenging. Just imagine the numerous devices supported by the networks, the many concurrent processes running on the computer's networks, and the computing demand, the evolving and changing system goals. So how could we design our systems, and how do we evaluate our designs? Now, in solving this challenge, in the recent article from my group, we define the key performance indicators of 5G into three dimensions. So as you can see, on the bottom gray cluster is on the connectivity level kind of KPI that include data rate, energy efficiency, spectrum efficiency, trust, security, privacy, reliability, latency. As a network, how good the connectivity is. Now, on the second cluster of performance indicators, which is indicated in the green, is the system intelligence and capability. That the system have spatial temporal awareness, the capability of doing sensing synchronization, the capability of supporting intelligent knowledge exchange. So are we intelligence ready for future? Now, on the third categories of the performance indicators is about how effective we can orchestrate the system in achieving our goals, the scalability, the efficiency, the agility. So that's basically our understanding how to define the key performance indicators of 6G and how to achieve the values of 6G-enabled systems. So in the next, I will share our research innovation along these directions. So let's first talk about the value realization through enhancing communication efficiency and effectiveness. As we know, radio resource is a critical resource for wireless communication. And although they are invisible, they are the bottleneck for future networks. Just imagine so many devices and the extremely high data rate we're expecting. So we created the first concept of non-orthogonal, which is overlapped or superimposed radio resource sharing. And by doing the interference cancellation and the signal reconstruction at the receiver side, we can successfully allow concurrent utilization of radio resources without creating mutual interference. And this has dramatically improved the spectrum utilization efficiency by over 60%. And by working with government labs in Canada, USA, and South Korea, this technology has been successfully adopted in the HDTV standard, which impacting a market with a value of over 10 billion US dollars. Now, more recently, we are working on the more challenging scenario where a base station has to support a wider variety of heterogeneous devices with different needs and different capabilities. So what we are doing is that we try to utilize the radio resources in a multi-dimension, not just the time, frequency, but also space, and also the power and code domain created by signal processing. So by exploring the multi-dimensional opportunities and also understanding each device's unique need, we are able to accommodate user-specific device in a more effective way. So we can accommodate more devices, yet improving each device's individual communication requirement. Now, on the second direction of the value realization, I want to talk about the creation of new capability that are beyond traditional communications. So this includes localization, sensing, synchronization, supporting of collaborative computing, and which is very important for future applications, particularly from vertical industries. So again, we are the pioneer in the world that first created the integrated local area locationing, tracking, and communications. And supported by D&D, we validated the technology. We designed the waveform protocols at Western. And right now, we are working on new mechanisms of supporting concurrent heterogeneous services while meeting the individual's device's need. There are new pathways in achieving value by providing enhanced security, privacy, and trust. As we know, those are the important aspects simply due to the critical applications we're using. However, the traditional security mechanism have many issues. The easily falsified digital credentials, the highly standardized security protocol, and also the increased overhead when we try to increase the security level, and which is very undesirable for machine communications. They need low latency. So our solution is to integrate the security into the communication process while dramatically reducing the overhead. So we exploring the device feature, hardware feature, including the amplifier, their antenna, sampling clock, carrier frequency offset, so on and so forth, as the fingerprint of each device for authentication. And also we use the communication environment, which is reciprocal to both transmitter and receiver as a shared secret to enhance the security. And we can achieve the desired security level by involving collaborators in improving the performance of the proposed algorithm. And more recently, we are working on the group authentication, where a group of machines need to mutually authenticate each other while we want to reduce the overhead, and we don't want to involve the central server as well. So that has a lot of implication for vertical IoT applications. The last direction I want to talk about briefly is using the trust as a new mechanism for value realization and goal-oriented collaboration. And simply because the diverse applications, the connected system, and we rely on collaboration due to the system constraint and also the operational objective. We need to complete the task in really low time, yet the device has limited resource and capability. So we rely on collaborator. However, selecting the collaborator can be extremely difficult and challenging due to the fact that different factors need to be considered that include the resource owned by the device, the capability, the willingness to help, the accountability. So what we have done is proposed a task-specific trust as a way to select our collaborators. And we utilize in enabling rapid collaboration among moving vehicles, where the vehicles don't know each other at all, but they need to enable rapid collaboration due to the safety-related implications. So that dramatically improve the efficiency, effectiveness, and value of the overall solution. Now, in the more complex scenario where you need to involve multiple collaborators, what we are doing now is that we decompose a complex task into a group of subtasks, and we will match the subtask with potential group of collaborators. So we're using a new mathematical tool, hypergraph, to enable this rapid matching. So we are expecting more exciting breakthrough from this emerging area. Now, very quickly, I want to summarize this presentation. So the future 5G 6G enabled system is complex, and particularly when we want to achieve its value realization. And in this presentation, we talked about 4 different directions through improving the effectiveness, efficiency of communications, enabling the beyond communication capability, integrated security, privacy, and the trust provisioning. And also the last one is using the trust as a new mechanism for value realization. Now, this indicating like a shifting of design philosophy in engineering systems from the performance oriented design to the outcome oriented innovation. And this also implying the interdisciplinary collaboration from, let's say, philosophy. So I want to thank you, everyone, for listening, and I look forward to the continued conversation and more interactions with the researchers on campus for value realization in the connected society. Thank you.